Hello and welcome. Hard to believe we are already kicking off Unit 4, the probability unit. So this unit's fairly short. You're going to notice Unit 4 and Unit 5 go by pretty quick. Unit 4, there's only 3 sections, and we're going to be covering 2 of them this week. And then next week, we'll finish it up, have the test review, and test next week. But looking at Lecture 4.1, Fundamentals of Probability, it's here we're going to introduce the multiplication principle, introduce basics of probability, and talk about OR probabilities. Now, the multiplication principle is this A counting method, which basically states if there's A ways of doing one thing and B ways of doing another thing, then there are A times B ways of doing both actions. So let's do a couple examples here. A restaurant offers 5 appetizers, 10 entrees, and 3 desserts. So basically, it's going to be our choice for appetizer times our choice for entree times our choice for dessert, which is basically 5 times 10 times 3, which is going to be 150, is the answer. So there's 150 different 3-course meals. So, suppose Jim rolls a 20-sided dice and 2 6-sided dice. How many possibilities are there? Well, you could view it as whatever happens on dice 1 times whatever happens on dice 2 times whatever happens on dice 3. Now, dice 1 is 20-sided, so there's 20 different numbers on it. Dice 2 only has 6 sides. Dice 3 only has 6 sides. So to compute that, you need only do 20 times 6 times 6, which will get us 720. So there's 720 different ways the dice roll can go. Alright. So now that we got the multiplication principle out of the way, we are ready to begin talking about probability. So, probability is a measure of the likelihood that a given result of a random phenomenon will occur. The probability of event E occurring is denoted P at E, and of course, probabilities between 0 and 1. Keep in mind 0 equals 0%, 1 equals 100%. So, if probability of event E equals 0, then that implies that E is impossible. Alright, if the probability is 0, that means that event is not going to occur. On the contrary, if probability of event E occurring equals 1, well, that implies E is guaranteed to occur. Alright, it's a 100% chance it's going to happen. And there's actually 3 types of probability. There's what we call theoretical probability, which is based on possibilities. So if you're computing theoretical probability of event E occurring is the number of ways E can occur divided by total number of possibilities. And this is assuming that all the different ways E can occur have equal probability. Now, theoretical probability is based on possibilities. Empirical, or what's also called experimental probability, is based on trials or observations. So in this case, the probability is given by the number of times E did occur. So you would record how many times that event actually happened and divide it by the total number of trials. So these two are quite different in perspective. Theoretical is based on possibilities. Empirical is based on observations. And then you've got subjective probability, which is a probability estimate based on experience or intuition. So not necessarily a whole lot of math in subjective probability, but it can be valuable. Look at sports. Sports is a great example. So you might have a very experienced coach or sports professional who will tell you that one team is more likely to say win the Super Bowl than the other. And they might not be doing a whole lot of math there. They're relying on their own experience and intuition, which can be valuable at times. But let's go ahead and do some examples. Let's compute the probability, and we'll start simple. Number one is asking, hey, what's the probability of getting heads on a coin toss? Well, there's only two possibilities. So what's possible on a coin toss? Well, you can get heads or you can get tails. There's only two possibilities, and only one of those lines up with heads. So you have a 1/2 chance of getting heads on a coin toss. In other words, 50%. Now, what's the probability of drawing a queen? So if you look at that standard deck of cards, you should know that out of all the 52 cards, there are 4 queens. All right, you got the Queen of Hearts, the Queen of Diamonds, the Queen of Spades, and the Queen of Clubs. So there's 4 queens out of 52 cards. And it's very important when you're doing these probability questions that you reduce your fraction. So remember, your calculators can reduce fractions. So this fraction reduces to 1/13 is the answer. All right. So what's the probability of rolling 3 on a 6-sided dice? Well, there's only one way to roll a 3 out of 6 possibilities. So there's the answer there. And here's where we get a little bit more complex. Number 4. What's the probability of rolling a sum of 7 when you roll 2 dice? So we got to count all the possibilities because you got dice 1 and dice 2. So this is where we're using that multiplication principle we talked about at the beginning of the lecture. So there are 6 possibilities on the first dice, 6 possibilities on the second. So when you roll 2 dice, there's actually 36 different possibilities. And what we have to do is we have to outline all 36 possibilities. So we'll use a chart to do that. So on the first dice, you can roll 1, 2, 3, 4, 5, or 6. On the other dice, you can roll 1, 2, 3, 4, 5, or 6. And you roll 2 dice, and you're taking the sum. So it says rolling a sum. So that means you add them together. So if I roll 2 ones, the sum is 2. If I roll a 2 and a 1, then it's a 3. If I roll a 3 and a 1, then it's a 4. If I roll a 4 and a 1, it's a 5. If I roll a 5 and a 1, it's a 6. 6 and a 1 is a 7. And you can probably see the pattern here, so we'll just go ahead and finish out this chart. And you'll notice it's a diagonal in nature. You'll notice that in just a moment. Alright, 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, 12. Of course, 12 is the most you can get, because the only way you can get 12 rolling 2 dice is if you get a 6 on each. Alright, so there's all 36 possibilities there in the chart. We want to figure out, hey, what's the chance of rolling a 7? Well, there's multiple ways to roll a 7. You can roll a 1 and a 6, a 2 and a 5, a 3 and a 4, a 4 and a 3, a 5 and a 2, or a 6 and a 1. So if we count that up, that's 1, 2, 3, 4, 5, 6. So that's 6 out of 36 possibilities where you roll a sum of 7. So when we reduce that fraction, it reduces to 1 in 6. So you basically have a 1 in 6 chance of rolling a 7, a sum of 7, I should say, when you roll 2 dice. Alright. So let's go ahead and look at number 5. So in example number 5, we got a bag that contains 3 red marbles, 5 blue marbles, and 2 green marbles. What is the probability you draw a blue marble? So we got to figure out all the possibilities. So there's 3 red marbles plus the 5 blue marbles plus the 2 green marbles. So there are 10 marbles in the bag. So there's 10 possibilities here. Now, note that we are not multiplying because it's a single event. We're not doing 2 events. We're not, drawing 2 marbles per se. Just figure out total number of marbles in the bag. So out of those 10 marbles in the bag, how many of them are blue? Well, that would be 5. So you have 5 out of 10 chance of getting a blue marble, which is, in other words, a 50-50 chance, or probability of 1/2 when you reduce the fraction. Alright. So, let's look at number 6 here. So, basically got a 3-child family. Got child 1, child 2, and child 3. So, what's the probability of randomly selected 3-child family has 2 boys and 1 girl? Well, for each child, there's 2 possibilities, male or female, male or female, male or female. So, there's actually 8 possible combinations. So what we need to do is outline all the possibilities. So what's possible? Well, it's possible that you have, and Lord have mercy on you if you do, all boys. Alright, 3 boys. Or you could have your first 2 children are boys and your third is a girl. So we've exercised or executed all possibilities that begin with the first 2 children being boys. Well, you could also have a pair of boy-girls, where the firstborn is a boy and the secondborn is a girl. So you could have boy-girl-boy or boy-girl-girl. So there's that pair. So we've now looked at every possibility where the firstborn is a boy, but your firstborn could also be a girl. And secondborn's a boy. So you could have girl-boy-boy or girl-boy-girl. And then lastly, you could have all girls, or the first 2 are girls and your third child is a boy. So there's all the possibilities there. So we can carefully look through that, make sure we didn't double count any. They're all unique. So then how many of those are 2 boys and 1 girl? That one's 2 boys and 1 girl. That one's 2 boys and 1 girl. That's 2 boys and 1 girl. And that's it. 3 out of 8. So there's a 3 out of 8 probability that a randomly selected 3-child family will have 2 boys and 1 girl. Alright, so that's kind of fundamentals of probability. We can also look at the probability of an event not happening. So in order to compute the probability that an event does not occur, we need only subtract the probability that it does occur from 100%. In other words, if I tell you that there's a 30% chance of rain today, well, you automatically know that there's a 70% chance of not getting rain today by simply subtracting from 100%. Right, because either the event happens or it doesn't happen. So if it doesn't happen, you just subtract from 100%. So compute the probability of not rolling 5 on a dice. So we start off with 1 minus, how many ways can you roll a 5? Well, that's 1 out of 6. 5 out of 6. Now, some of you may have jumped to the answer right away, and that's perfectly fine. What's the probability of not rolling a 5? Well, that's the same thing as rolling anything that's not a 5, and there's 5 numbers on the dice that are not 5, so 5 out of 6. Now, let's look at number 2. What's the probability you don't draw a heart card? So that'd be 100%, which is 1, minus how many different hearts there are. So, if you look at the deck of cards, there are 13 hearts out of 52 cards. So when you compute that, and feel free to use your calculator if need be, you're going to get 39 out of 52, which reduces to 3/4. And if you're familiar with the deck of cards, that should not surprise you at all. Because there's 4 suits. You have hearts, diamonds, spades, clubs. Alright, there's 4 suits, and each suit has the same number of cards. Thus, the probability of not getting a heart is going to be 3 out of 4. Because how do you not get a heart? Well, either draw a diamond, draw a club, or draw a spade. Alright, suppose there's a 40% chance of rain today. What's the probability it doesn't rain? Well, that's 1 minus 40%. Which is 0.6, which is, in other words, 60%. So, again, just subtracting from 1 tells us the probability of an event not occurring. So, let's go ahead and do a comparison between theoretical probabilities and empirical probabilities. So here, suppose you roll a dice 100 times and record the following results. So you roll the dice 100 times, you notice it lands on 1 42 times, it lands on 2 12 times, 3 11 times, 4 10 times, so on and so forth. Complete the table below. So Let's compute theoretical probability. Now, theoretical probability is based on possibilities. It is not based on observations. So we don't care about those observations for theoretical probability. We're just looking at the possibilities. So if you want to roll a 1, that's 1 out of 6. If you want to roll a 2, that's also 1 out of 6. If you want to roll a 3, it's 1 out of 6. All of these are going to be 1 out of 6. And if you want, we can approximate those as a percentage. 1 out of 6 is approximately, 16.7% roughly. So all of these have an equal probability. So if we look at the theoretical probability, all these have just under a 17% chance of likelihood. Now let's look at the empirical. The empirical is based on observations. So empirical probability of rolling a 1, well, we rolled a 1 42 times out of 100 attempts. So that's a 42% empirical probability of rolling a 1. And then we rolled a 2 12 out of 100. Well, that says 12%. We rolled a 3 11 times out of 100, which is 11%. We roll a 4, looking up above, 10 times out of 100, which is, of course, 10%. We rolled a 5 13 times out of 100, which is a 13%. And we rolled a 6 12 times out of 100, which is a 12%. And what we can do is we can compare the theoretical probability to the empirical probability. So you'll notice that they are quite different. Look at the probability of rolling a 1. If it were a fair dice, then you'd have, a 16.7% chance of rolling a 1. But this dice, the 1 popped up 42% of the time. So almost half the time, this dice was landing on 1. So part B, should you be suspicious of this dice? Yes. And that's because the theoretical probability and empirical probability are very different. After 100 trials. Now, you can't compare these two unless you do a bunch of trials, right? If you only roll the dice like 3 times, then of course the two are going to be very different. You need a lot of trials. But if you have a lot of trials and there's a big difference between the two, then that's a good sign of foul play, right? Something's fishy if those two are not similar after an extensive number of trials, right? If I flip a coin 100 times and I get head every single time, that should be suspicious. Why is it suspicious? Because the theoretical probability is not lining up with the empirical probability after a large number of attempts. So last topic in this section, we're going to look at OR probabilities. So let's go ahead and look at this definition. 2 events are non-overlapping if it is not possible for both to occur at the same time in a single trial. So basically, when it comes to overlapping, you're just asking, hey, can these happen at the same time in the same attempt? So is it possible to draw a card that's a king and red? Yeah, there's some overlap here. These 2 events are overlapping, right? You could get the king of hearts or you could get the king of diamonds. Those are red kings. But is drawing a king or drawing a queen overlapping? Well, can you get a card that is both a king and a queen? No, that's not possible. So this is non-overlapping. Those 2 events cannot occur at the same time in a single attempt. What about rolling even or less than 3? Well, is it possible to roll a number that is both even and less than 3? Well, what if you roll a 2? 2 is even and 2 is less than 3. That means there's some overlap between these 2 events. And then rolling even or odd, well, that's of course non-overlapping. There's no way you can roll both even and odd at the same time. Now this overlap is going to be very important when we start discussing OR probabilities. So when computing the probability of one event or another occurring, we must be careful to not double count any events. So in other words, we can't double count the overlap. So to compute the probability of event A or B happening, you take the sum of the probabilities and subtract the probability of the overlap. So let's look at an example. Looking at number 1, compute the probability of rolling even or less than 1. So the way you would do that, probability of rolling even or, less than 4. Well, that's going to be the probability of rolling even plus the probability of rolling less than 4 minus the probability of the overlap. In other words, even and less than 4. So the probability of rolling an even is 3 out of 6. The probability of rolling a number less than 4, well, that could be 1, 2, or 3. That's 3 out of 6. And you see why we have to use subtraction here. If I stop here, you're going to get 6 out of 6, which is 100%. And that can't be correct. You do not have a 100% chance of rolling an even or less than 4, because what if you roll a 5? Right? If you roll a 5, that's neither even nor less than 4. So it's not 100%. So we got to subtract the overlap. So what's the probability you roll something that's even and below 4? Well, how many numbers are even and below 4? Well, that's only rolling a 2. One event. So minus the 1 out of 6. And there you get the correct answer, which is a 5 out of 6. And it makes sense. You can see what I mean by overlap. If we look at all the possibilities when you're rolling a dice, you can roll a 1, 2, a 3, a 4, a 5, or a 6. So if I circle everything that's even, 2, 4, 6, and I put a square everything below 4, so square around 3, square around 2, square around 1, you can see our problem right there. We have an overlap. We accidentally double counted that 2. We don't want to double count when we're computing an OR probability. So that's why we got to subtract that one event that was double counted. So let's look at the next example, drawing a king or a queen. So that's going to be probability of drawing a king, which is 4 out of 52, plus probability of drawing a queen, which is 4 out of 52. And then ask yourself, is there any overlap between these two? Is there any card that is both king and queen? The answer is no. So here's a problem where you don't have any overlap. So it's a bit simpler. So that's 8 out of 52, which reduces to 2 out of 13. And what's the probability of drawing queen or black? Well, the probability you draw a queen, well, there's 4 queens, and half the deck is black. So half the deck would be 26 cards. And then ask yourself, is there any overlap? Did we accidentally double count anything? Well, if we look at this first probability, we did double count, because in the first probability we counted the queen of spades and the queen of clubs. Those are 2 black queens we counted here. But we also counted those 2 black queens in the black card probability. So we need to subtract those off. There's 2 black queens that we double counted, and we don't want to do that. And that gets us a 28 out of 52, which reduces. So we'll let our calculator reduce it for us. And that reduces to a 7 out of 13. So slightly better than a 50% chance. Alright. Let's look at just 3 more examples. Looking at example number 4. Compute the probability of rolling 2 dice and getting a sum of 6 or sum of 8. So if we roll 2 dice and take the sum, there's 36 possibilities. So it's that same chart we did earlier in the lecture. So let's outline all the possibilities. You could roll 2 ones, in which case you get a sum of 2. You can roll a 2 and a 1, 3. So basically every single time you're just adding 1. Add 1, add 1, add 1. It's a pretty simple pattern. So we're just going to quickly go through all the possibilities here of rolling 2 dice. Alright, so what's the probability of rolling 2 dice and getting a sum of 6? Well, that's 1, 2, 3, 4, 5. So there's 5 different ways. 5 out of 36 gets us a 6. And what about rolling an 8? 1, 2, 3, 4, 5. 5 out of 36 for an 8. And is there any overlap there? No, there is no overlap. They are completely mutually exclusive. So add them together, that's 10 out of 36, which will reduce for us down to 5 out of 18 is the answer. Alright. So a bag has 8 red marbles, 10 blue marbles, 2 white marbles. So that tells us there are 20 marbles in the bag. Compute probability of drawing red or white. So 8 out of the 20 are red, plus 2 out of the 20 are white. And is there any overlap there? Is there any marble that is both red and white? Nope, no overlap. So the answer is 10 out of 20, which is 1/2. So you got a 50% chance of drawing a red or white. Alright. And last one, flipping 2 coins and getting both heads or both tails. So here we want to look at all possibilities. So there's 2 possibilities for each coin toss, which means there's a total of 4 possibilities. You could get heads and heads, heads and tails, or you could get tails and heads, tails and tails. So flipping 2 coins and getting both heads, both tails, well, that's 2 out of 4 possibilities, which reduces to a 1/2 chance, 50% chance. Alright, and that's a wrap. So there will be a folio quiz over this lecture, and then another pencast with a worksheet to finish up the online module. Keep up the hard work, guys, and just let me know if you have any questions. And also don't be afraid to utilize those virtual tutoring services if need be. Have a wonderful day.